Hi, I'm Cliff Click, and I'm here to tell you about my startup war stories. Let's see if I can figure out how to get my mouse going here. Yeah, who am I? Okay, so Cliff Click. So I've been running startups, been second in command in a bunch of startups for about 15, 20 years. I've been coding since I was a little kid. I wrote my first compiler when I was 15. That was a long time ago. I did the core guts of the Java virtual machine, the major JIT. I've done machine learning tools, I've distributed scale out, big data, big math programs. I've done low latency GCs and device drivers and OSs and distributed sensor systems and all kinds of fun stuff. Okay. So the talk's a little old, but it's the same stuff. Been in startups closer to 20 years now. Azul as a big Java hardware, supercomputer Java hardware, basically. Hundreds and hundreds of cores in a single machine, read and write barriers, hardware transactional memory, very, very low latency GCs, bunch of stuff. H2O, big data, machine learning tools, parallel distributed tooling, the fastest exact KV store on the planet, sort of easily measurable, bleeding edge ML algorithms, Neurensic, finding fraud in the stock market on 1 billion transactions a day, bunch of fun stuff here. So why be in a startup? Because you can be your own boss, because you can tackle real problems, fix what's broken, because you got no time to be micromanaged or to micromanage, because what you do makes a difference, both actually good and bad. And because there's in the background, there's this notion of a lottery ticket that maybe you'll get a big payoff. You're in it because it's fun, you're having a great time, you're solving a real problem, maybe you win the lottery too. Okay, why not startups? Because you have to be your own boss. You have to sort out what's important and what's not. And you have to work on what's important, not on what's fun. And so it's all great to start a startup because you're doing something that's fun and important. But some point in there, you start to have you do what's important, not what's fun. Finances are unsure, sometimes good, sometimes bad. It's a roller coaster ride, up and down, missing paychecks. I got a story about dropped insurance that's kind of ugly. Seedy characters. I've met some really fantastic people, some really fun people, and some really shady characters who basically rob the startup blind. Please still have a job for a reason. That veneer of civilization is still plenty thin. So let's talk about the major startups. Here's Azul. I walked from Sun to Azul because the management at Sun was effed up. And I was unable to make progress. I had a lot of cool stuff I wanted to do in a JVM, but bad management couldn't do it. So I came in as employee number 12 at Azul, and there was a hardware CEO, and it was a hardware company with a hardware mindset, trying to do a big server hardware on Java, which is a big software stack. So there was some company culture shock there. These guys are going to solve all the problems with hardware, but they knew they needed software, but I was not employee number 2. Okay. Fun stuff now. I get to explain to hardware guys about JITting. They had no clue. They had all this cool shit for interpreting Java bytecodes. Nixed it all. Build a better JIT target. Ditch a bunch of special gear for inline caches, for virtual calls, because inline caches work great. The end result, I get a 32 register, 64-bit, simple 3-address RISC, super easy JIT target, compiler writer stream, greatest chip I ever wrote code for, fun stuff, and 24 cores in a die in 2004, right? Wrote big chunks of the hotspot right then and there. Much of the core runtime, all the threading stuff, all the exception stuff, all the stack crawling stuff. Done over 3 months. Shit, I wanted to do it, son, and couldn't do. The end result was checkpointing single threads in nanoseconds. That turned into the lowest latency GC on the planet, and it still remains a decade later the lowest latency GC on the planet by a large margin. The Azul collector is like an amazing thing. Okay, integrated C1 and C2. At that time, you could run one or the other, but their runtimes are not compatible. GC read and write barriers, faster unblock block threads, single word object headers, hugely less code and complexity. By the way, single word object headers, it saves memory, but that's not what it saves. It saves cache footprint, which gets to more performance for the same amount of work you're doing. Okay, 2 years before we had silicon, we wrote a really fast simulator. We could boot the operating system and boot Java, Java-exe, and run Hello World on simulation. That included running the JVM startup, initializing the heap, initializing the interpreter, and writing bytecodes. We used the simulator to find all these JVM bugs. We had a weaker memory model. I was swapping bugs with Steve Goldman at Sun on his Itanium port. I did the JIT for Itanium while I was at Sun, but the runtime work was still being at Sun, and Steve and I went back and forth there. Best data race detector tool I've ever used. and best cache-aware profiling tool I've ever used, but those are other talks. First chips come back, busted L2. You can only run 1 core instead of 8 on an L2, and only 1-way associative instead of 4-way associative. Still lots of errors, mostly corrected by ECC. So you ended up with 3 cores on a die because you had 8 cores per L2, except only 1. Your branch predictor bits were bleeding into the register path, which you fixed by JITting only the even addresses and only using even number registers. So you had half the number of registers as well. And you still had to overvoltage the chips, which meant they slowly cooked to death because electron migration in physics is real. All fixed in the next chip revision. We get a 3rd revision eventually for a security bug. Chips are stable. We get minimum 2 cores in a single slot. So 48 cores is the minimum box, up to 384. Unheard of scale and bandwidth. For a while, we were on the top 500 supercomputer bandwidth chart because we had just huge bandwidth. Each core, though, was about 1/10 of an x86. So a full out box was about 40 x86 equivalents. And a minimal system was still like 5 x86s when you could get no more than 2. So it looked kind of good on paper, except you had to have highly parallel workloads. I could run the entire TCK, excuse me, in 20 minutes. Background concurrent collector, because we have cores for days, they can run all the GC in the background. We were in the low millisecond range pretty quickly on a 512 gig heap. Back in that day, these numbers were unheard of. This is 15 years ago, unheard of numbers. This worked wonders on many kind of applications, especially big web portal apps like you'd find on Amazon. And we had all this cool hardware for low-cost virtual calls, array references, rain checks baked in, register windows. Everything's working as expected. Hardware transactional memory, all of L1 could hold a transaction. Giant transactions were possible. Turns out it doesn't actually work in practice because of other reasons having to do with people not writing HTML-friendly code. Different story, different talk. Fine. We find lots of bad Java code, which is working on the x86 memory model, not the Java memory model. Since we were the Java memory model, but we were not the x86 model, this code broke. And we had to go debug other people's Java code that's working fine on x86. And it really cut into how you could sell things. People were changing final fields using reflection. They had bad weak reference usages for the GCs, didn't play well, and all kinds of stuff. But the true killer here was the cores were too slow. Very few apps are designed for so many slow cores. And you can only crank up that parallel knob so far. People were just used to a few fast cores. The 2nd generation chips were a lot faster, faster clock rate, double wide issue, hit under miss cache, bigger caches, so on and so forth. Still about 1/4 of an x86, still too slow. And I went through a divorce. Azul was a good employer, but it didn't give me a lottery ticket. And I went through an ugly divorce. I got a lot of support from Azul, but the moral of the story here is startups can and do cause divorce, really. It's just stress, huge amounts of stress. Not Azul's fault, and in this case, divorce was in the cards some decades ago. We were just waiting for the trigger to hit the right point. Straw was going to break the camel's back anyhow. Ultimately, I moved on in both senses. Steve Jobs died. I'm coming out of the depression, really, from the divorce. I had this philosophical moment. What am I doing with my life? So I co-founded a new startup. This is redundant array of inexpensive nodes, RAIN, ideas, a better KV store using disk RAID ideas, hardware coherency concepts, but on a standard cluster of JVMs. Lots of fun water ponds. Great. We're building a distributed KV store in Java. I ended up with some 3 machines in my house, some laptops, some old, some new machines, whatever, mix of hardware. I'm debugging Paxos and multicast and NIO buffers, and the list goes on and on. A lot of new text for me. I can add and kill nodes freely. I get rapid replication of the data. I can be consistent, exact, and fast. I can have it all. I give up a bit of availability if the network split is above a certain large threshold. Other than that, small count drop nodes, no, I have consistent, exact, fast. It's great. Fastest KV store, easily benchmarked against other ones. I am as fast or faster than the fastest ever benchmark. Still to this day, H2O's KV store is amazing. Walk into Apple to demo this thing, set up a 5-node cluster. We're carrying literally a 5-node cluster in a backpack of 5 Linux notepads. Using the Apple guest Wi-Fi. The cluster's up in seconds. Big ho-hum. KV store market is just saturated. We're clearly faster and exact. We can add drop nodes, we're reliable, we're stable, The theory it scales out freely, not good enough to move from an existing solution. Tried again at American Express, yawn. Hey, you guys know anything about this new machine learning stuff? And we're like, sure, we know something. And we run off to Starbucks, and I spend the next 3 hours coding up a parallel distributed version of the high school, least squares best fit line. Go back to Amex, and they're like, wow, you guys got something here. And we're like, really? Okay, run home, pivot time. Give up on selling a KV store. HTO still has a really nice internal KV store. We use it all the time for controlling big, complicated machine learning algorithms, but it's not what we sell for. Head to the big data market. So I have to get ETL figured out. Parse CSV files, parallel distributed scale out. CSV is a loosey-goosey spec. This turns out to be a much more harder problem to solve than you might think. We get there in that we can basically parse CSV files as fast as your fast network can deliver them, memory bandwidth speeds, and turn them into columnar compressed store. And we get a bunch of basic algorithms, and we start upgrading, the 2D best fit to a generalized linear regression. We hire Jan Vitek, who's a really nice, really smart guy, and he says, random forest. You guys want to do random forest. So we try to figure out how to parallelize random forest and how to parallelize big data in any case. And we rotate through a bunch of iterations. And we finally get something together, and we go demo it to Amex, and we lose out to Skytree, which is a single node solution who's doing random forest forever and a day on one node. And they're doing it right with the math. And we now figure out that we're losing because we're not doing the math right. We're a bunch of software systems engineer geek heads, not math geek heads, and all these funny notions about NA bits and range lists and I can't remember now all the parts we went through. We missed out a bunch of bits. We got the core algorithm, the basic version correct, but we didn't do all the corner cases right, and that's where you get the precision in the algorithm. So we got the fussy bits right, and along the way, we had to redo our parallel infrastructure, and we ended up with a much better one than the first cut. It's always the case. Columnar compressed store, seeing about 2x better than gzip on disk on big data sets. These days, it's 3 to 4. It varies. It's all over the map, but you can routinely get better than gzip on disk by a fair amount. We never decompress in memory. We only decompress hot in your registers, really, not even in cache. And so we can do math at the full memory bandwidth speeds of the compressed data. Really, really fast for doing math. First parallel distributed GBM algorithm. We end up running generalized linear modeling on a 7 terabyte data set in 90 seconds on a 100 node Amazon cluster, looking at doing R and big data. Go through your growing pains. The first fire, first hire is fun. First fire is super painful, but just not a good fit. Team keeps growing. We learn hire for enthusiasm, not necessarily experience. Excited people learn fast. If they're also experienced, that's better. We get this old ex-startup 50s era house sitting behind a Taco Bell's, the company cafeteria, $2, 2 minutes, back to work, right? One of the fun stories, we set up a little data center in the back of the house. It's the rear bedroom, 2 racks of servers in a small room with fans. And I'm running the first time the 10 node parallel map reduce as part of the GLM. I hit the go button, power goes out. Oh God, we have to go, figure what happened, flip the breakers, reboot, start everything up, get everything going again. I set up the cluster, I start it again, boom, power goes out. Okay, once, unlucky. Twice, there's something going on. We think about it. An x86 at idle, 100 watts. I got 10 of them. Going full bore, 300 watts. That's 3,000. And sure enough, they're on cheap-ass hardware store power strips. Yes, power strips, chained, cheapo power strips. So time to upgrade. And we discover there's a bare 240-volt line in the attic that also bypasses the power meter. This house used to be a grow house, an old marijuana grow house. When we asked the owner to upgrade the power, the owner's maintenance man calls PG&E, who says, oh my God, you guys got an illegal power, you've been stealing. No, we haven't, but somebody had been stealing. They rush out in our killer power. Suddenly I got 10 engineers and no power. So we grab those damn power strips and we run to Starbucks, and we grab the big table in the middle of Starbucks for the next week. Owner comes in with a diesel generator because he's rented us a house with no power now, and set it up, big toad behind diesel generator in the front with a cable like this coming through the front door of the house. Next 2 weeks, this thing's going bump, 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 bump. But we have power. Electricians are bringing the building up to code for a business. We rewire the whole building in 2 weeks. Literally, I'm trying to code in the building when I have saws all in the ceiling, and bits are falling on me, and the chunk comes down. The guy's cutting a hole in the ceiling to drop the power line and the internet cable and everything else to come down through. Fine. We get a functioning big data machine learning tool. I'll claim vastly easier than Spark to set up and run. I'll also claim this one's easy to measure, 10x faster to do any of your basic analytics. better algorithms, but harder to use than R and Python by a lot, and a lot fewer algorithms as well. And we walk into Netflix for demo and we crash on startup. And when the system's not robust, it's not resource limit aware, so it's easy to run it out of memory. There are some growing pains going on here. And it turns out that it's an enterprise sales cycle. It's a long sales cycle. You have to do lots of POCs without a sale before you get one. And lots of, if you do this, we'll also, we'll buy it. Customers know that machine learning is the new hotness. It's going to save the day or whatever, but they don't know how to do it well. And they really want hand-holding or consulting, not a better tool. But you can bring your better tool if you want, but they want the hand-holding. So we're not really geared to be a consulting company, right? Team keeps growing. I keep getting conflicts with my co-founder. I don't like how he treats people. I'm spending more and more of my time keeping people happy and not making product. And he's basically hiding finances from me. He's not willing to take help or not wanting to talk. And I'm getting shut out. And it finally reaches a breaking point and I have to walk. I hate to accept sabbatical, and I have to have a recharge time, and that's a learning too. That you pour your heart and soul into these things, and when you're done and you walk away, you need a clean break. You say that was a good try, it was a good experiment, done, walk, and then rest and recover. And when you're ready to go, go again. So weird connection for a crazy guy doing ML on stock market data, looking for fraud. And he's an algorithmic trading writer, and he's trying to defend himself from other people defrauding his algorithms. He has a demo. He wants to scale it up. He's actually caught a guy the CTFC was trying to catch on the same set of data. And I've been curious about fintech. Okay, I want to go. So I head in. Turns out he's got an existing team of 15 engineers, been working for a year and a half. Stuff's not coming together. The current CTO of David is a good buddy. He's a good hacker guy, nice, but he's not really VP Eng or CTO material. So I'll figure out to sort out the Chicago team and add some continuous integration, so lots more testing. The product's overly complicated. There's a database in 5 different languages, and there's no product yet. There's some red flags going off, but I think I can sort it. So there's no technical leadership, and it shows. The team is totally dysfunctional. There's no direction. There's lots of lone wolf hotshot types. There's no integration plan. And basically, Cliff shows up and the party's over. Most of them leave in 6 months, and I hire 4 good guys from Silicon Valley and go from scratch. And in 6 months, we have a product that's running and working, and vastly simpler and vastly faster, and it's way the hell easier to figure out what's going on with it. And we find fraud, and we find lots of it. And the product is fast and accurate. 5% false positive rate, down from a 95% false positive rate for the industry standard. Installs in minutes. It's getting more and more robust over time. I got that the first time user experience right. Got a modern GUI. I'm literally replacing people who are cut and pasting from IBM 360 green screen emulators to an Excel spreadsheet. That's their current workflow. This is what I'm replacing. So it's like super low bar, and I'm not like jumping many technology levels here. I'm getting big data exploration from the browser. Customers are excited. I get compliance officers literally in tears. Like in 10 minutes, I can walk in and say, from 10 minutes when we hit your server room, you'll be looking at the fraud. And they're like, no way. And I was like, sure, just take us up on it. We do. Every time you install a jar file, you boot it up, you're pointing out their data set, it inhales in seconds. Minutes later, they're looking at the fraud. And I'm showing them tick by tick, this is a fraudulent behavior, and here's why. Slow-mo, full-speed movies, good explanations, good table of provenance, this from here, this data from here, here, all brought together, and here is the fraud and why it's fraud and what it is. Boiling down a billion transactions to a handful. People are just loving it. We end up hiring this old school bank sales guy who's been in the business a while, and he's an expert at selling to banks. And actually, he loves a high rolling lifestyle, and he gets no oversight because David just hands him a company credit card and lets him go to town. And he does crazy ass shit with that card. First class travel all over, $3,000 meals, single meals, trips to Mexico with his girlfriend, not his wife. Burns through $1.5 million in 6 months before we catch him. Wow, David means well, but he's not really experienced as being a CEO. And mostly he's in love with the idea of owning a startup, but not in love with the idea of doing what it takes to run a startup. So I hear about the bad stuff too late. And it's just the errors of the leadership team being split between Silicon Valley and Chicago. 3 days, not hear from David, and I'm like, what's going on? So I call him on the phone. Hey, David, how's it going? He's like, oh, stall. And I poke around realizing there's something going on, stall. So next day I get the full story after he's made the mistake, and I can't correct it. One of them was out of money, so he missed his payroll with no warning to anybody. Suddenly the employees don't get a paycheck. They can't pay their rent. I don't have health insurance. I don't even know I don't have health insurance. And my son has a grand mal epileptic seizure with no health insurance. Oh my God, it took me 6 months to clean it from that disaster. Desperate scramble for some cash, but really by the time you're desperately scrambling, it's too late. We should have done this kind of planning and work a long time ago, and David just was not the guy to sort that with me, unless I was there in Chicago. Long enterprise sales cycle needs planning for long cycles. Customers may love it, they may want it, but they have to wait themselves till their next funding cycle rolls around, and you have to plan that into your funding cycle, right? Eventually, it burns out. People need to get paid. We fire sell the technology to a decent company. Really sad. Good market, good product fit, wrong CEO. I'm me still learning how to pick CEOs here. So startup journeys. Wow, lots of wild rides. First sale, first fire, first quit, working at Grow House, running a largest engineering team, building some awesome tech, custom Java hardware, fastest KV store on the planet, first parallel GBM algorithm on the planet, GLM on 7 terabytes, finding real fraud, meeting all these crazy people, some good, some really, really bad. If you can handle the adrenaline rush, I totally recommend it. If you want to pay your mortgage and your college funds, maybe that steady paycheck from the big corp looks good. It's an easier thing to do while you're young and don't have a lot of dependencies. But I'm very happy to take this journey, and I'm ready for the next one, which people have knocked on my door recently even, and I'm poking at them. And independently, I am doing cool stuff with a new language I call AA, not on this slide here, where I think I've integrated Henry Milner and forward flow typing with aggressive partial evaluation. There's a story there that's in the works still. And I'm doing teaching occasionally under Rocket Real Time, which actually should reach out to me because I've put that aside while I'm doing the language things. Bam, I'm way over time, so that's it. And I'll be available after this talk for real-time talks, real-time Q&A. Thanks, bye-bye. Stop, no, stop.